spectroscopy, specifically using these tools that are available to us. We're going to power through just a couple of questions, and then hopefully you'll be on your way to solve this problem on your own. Okay, so we're going to go ahead and take a look at problem number 20 here, which is beyond where I'm hoping you to go for your little practice here. And what we're going to do is we're going to go ahead and start by looking at the IR spectrum first. And we're going to go ahead and look at a couple of key zones in particular, okay? And the key zones that we're going to start with, we're going to look here, we're going to see that we have no kind of big indicator in this section here, which means that we're not going to have any OH bonds, okay? And now we're going to go ahead and kind of pick and choose what we're looking at. And we're going to take a look at this big, strong signal here. And this big, strong signal is right at about this 1700 mark. And I'm going to go ahead and say that I am fairly confident that we have a C double bond O right here, okay? And the reason I'm confident of that is that we have this strong signal, and that's kind of like the only thing that really shows up in that spot, especially in our particular level that we're looking at it here, where we kind of sit for this section. Now, the next thing that we're going to do is I like to always look for some rings, and we're always going to be able to see rings because we're going to have like a little band here that's a little bit weaker here, okay? And this weakness is kind of indicate, especially right over here, that we have some sort of aromatic ring. And at this moment, I don't actually see that, so I'm going to go ahead and say we do not have an aromatic ring here. The next one I'm going to take a look at is this one right here, and this is going to go ahead and say, hey, you have specifically a bond that's going on. That's a CO bond here. Okay, so that means I have a CO single bond here. Okay, and this CO single bond is going to go ahead and clue me in as to the fact that this is another functional group that's in this molecule. Okay, so we have our main functional groups in here, and we should be able to say, shoot, this molecule has a CO bond and it has a CO double bond. That's either going to be a carboxylic acid or it's going to be an ester. And in this particular case, since we have no OH group, we know it's an ester. Now, the next thing that we have to do, we have to go ahead and specifically look at our mass. And we're going to take a look here. We're going to take a look and see that we have 88. And we have this little line at the bottom, which lets us clue in that 88 is the real number that we need here. And we're going to take out the amount of oxygen mass that's there, okay? Once we do that, we're going to go ahead and get our nice number of 56. And we can also go ahead and take a look at the hydrogens here. And this is telling us how many zones of hydrogens there are and how many of them are in each zone. And it looks like we have 1, 2, 3 zones. And in those zones we have 3, 3, and 2. Which means that we're going to go ahead and be able to take out a total of 8. Which means that we're going to be left with 48 for our number that's going to be part of our carbon. And we're going to go ahead and divide that by 12, which will give us 4. Okay? Which means that our formula is going to end up being C4H8O2. Now, at this point, we're going to have to go ahead and draw our molecule. Okay? Now, we've already determined that it's going to be an ester, so that means that we're going to have draw in our carbons right here. And I know that I'm going to go ahead and have a double bonded O right here. Okay? And I am also going to have to go ahead and include an oxygen right here. I'm going to go ahead and take a quick mental note that here we have some splitting. This is going to kind of represent these two hydrogens right here, the ones that are really close to this oxygen right here. They're getting split up and their signal's getting split up. And then these two ends here are going to kind of represent ends of our molecule right here. We're going to go ahead and now submit our answer, and we're going to happily celebrate us being as clever as we are. Okay. Now, the next thing that I would like us to go ahead and do is we're going to go ahead and do one more here. So we're going to go ahead and shoot ahead here to another great example. That's going to be number 29 here. Okay, and I'm going to go ahead and click all here so that I get them all right here. And we see that we have a fairly large one here, but it's not going to really affect us as much as we think. Okay, now this one here goes ahead and shows us a new group right here. We should see that we have this right here, which is a nice OH bond. Okay, and we're going to notice that because that shape is just so unique right there. Okay, so we have such a unique shape right there. And then we're also going to go ahead and take a note that here we have that strong or a stronger signal here. Okay, now our line is going much deeper down here in this 1500 zone. Okay, and it goes a little bit past here. This is going to go ahead and indicate kind of our aromatic compounds here. Okay, and we're going to notice that when it's like right here. Okay, so that means that we're going to have an aromatic compound. So we're going to have one of those carbon rings, and we know it's going to be there already. And we're going to go ahead and have an OH. Okay, so I'm going to just go ahead and put another carbon here, and it won't let me do that, of course. And we're going to have an OH in there as well. Okay. Now, the next thing that we want to do is we want to go ahead and take a look at our masses. Okay. And in this case, we know we're going to take out an OH. We're going to take a look here. We're going to see that this line here is right at 150. We have another line that goes forward. So I'm going to go ahead and use my 150 to go ahead and specifically be my starting point here. Okay. I'm going to go ahead and take 16 away from 150. And when I do that, I'm going to be left with 134. Okay. Now, with this 134, I'm going to go ahead and now take a look at my hydrogens. Okay. And I'm going to go ahead and count these up. So I have 5, 2, 1, 1, 5. Okay. So that means that I'm going to have a total of 14. So I'm going to go ahead and subtract 14 from here, and I'm going to go ahead and see that I have 120 mass left over. That's easy math for me to do in my head. I'm going to divide that by 12, and I'm going to have a total of C10, H14, O. Which means that that's the total that I'm going to be working with. I'm going to notice that this is pretty low here, and without doing any actual conscious thinking, because this is nowhere near as high to double of this is what I would see, I'm going to feel pretty confident in my carbon ring theory as we go forward here. Okay. Now, I'm also going to go ahead and note that I have 5 of them that are all the same. Okay, now typically what happens when you have 5 all the same, that's going to indicate that all of them are kind of in the same kind of distance away from your main molecule. And this is going to say that I have also a whole bunch of them that are and these ones are going to be at different spaces away from our molecule. Okay, so basically, what I'm going to see is this is going to be where at least 5 of them are. And I know that I'm going to have 1, 2, 3, 4, 5 different zones. Okay? Now, I only have 4 carbons to draw. So I've drawn 1, 2, 3, 4, 5. Okay? And then I'm going to add this OH. And now, when I go ahead and do this now, I'm going to see that I have 1, 2, 3, 4, 5, and 6 different zones. But I want to specifically note that this 3 here is kind of representing a zone where it's pretty far away from the OH. And I don't really have a zone where I have 3 that are far away from you, okay? So I'm going to go ahead and actually remodify my image here. And I'm going to say that I'm going to put 1 here, 1, 2, 3, 4. And then I'm going to put it here, and this is just to help satisfy this last little bit, because now these 3 are all alone right there, okay? Again, for the most part, I'm more concerned with you getting specifically what the functional group is that we're looking at and being able to answer the questions from there. This one was a little bit more difficult, but our same process for finding the functional group and everything else is the same. So at this point, go ahead, take your time, work on those questions there, and good luck.